Let's do this. Example 2. Consider the differential equation dy on dx minus 3y equals 3. Show that y equals this is a solution to the differential equation for any constant c. Now, just like we've done back in u sub and so on, you want to keep your x's on one side, your y's on the other side. So what we're going to do is go dy on dx is equal to 3 plus 3y. At this stage, I will be dividing my 3 plus 3y to my left-hand side and my dx to my right-hand side. So it will look something like this. Does that make sense? And was there ever a d by itself like that? Not really. We always had the integral sign with it as well. So we're going to put the integral sign as well. Integral, integral. And that is the idea of differential equations. That concept is the idea of differential equations. Is that okay? All right, we're going to continue now. What's the integral of 1 dx? X plus c. What's the integral of 1 on 3 plus 3y? Well, that's a log. So it's actually 1 on 3 log 3 plus 3y. Don't write a plus c again. You only write it once. So, yep, continue. It says, so from now on, when we say is a solution or solve, it just means integrate. So solution or solving means to integrate. Okay. Anyways, I'm at this last line. What do you do now? We're going to multiply obviously by 3. So I get log 3 plus 3y is equal to 3x plus, let's call it 3c for now. Then what do you do to get rid of the log? Exponential it. We have e 3x plus 3c, and then obviously take away 3, divide by 3. Now, for those who have done it, they can tell us why it looks a little bit different to what the question's telling me to find. I hope. Okay. No? Why does it look a little bit different? I don't know. Did your teacher emphasize the whole idea of differential equations at this stage? The C. Say it again? The C. Yeah. So what's the idea of the C in this topic? Okay, that's okay. Look, we actually use a capital A. Do you remember back when we used, do you remember when we did rates of change back in year 11 and we wrote things like this? Like an arbitrary term. Yeah, right? We used A's. I like A's still. I really like A's. I don't like using C's because C's should be left for constants. But the idea is this, A or A naught or whatever, it can be anything. It can represent anything. It can stand for anything, whatever. Yep. So if I said A naught can be A naught can be C, A naught can be 3C, A naught can be e to the 3C. As long as it's all constants, A naught can equal to A, can equal to anything. It could even equal to Sam, as long as Sam is a constant. It can. You got to understand that logic. So therefore, we've got to find the constant value in this term. Well, the constant value is this, e to the 3x dot e to the 3c on 3 minus 1. Do we agree with that firstly? So what I just did, let's zoom in. Yes. What I've just done is split up my power of my index laws to a multiplication of e to the 3c on 3. Now, isn't e to the 3c on 3 just a constant? One more time. Isn't e to the 3c on 3 just a constant? Forget c as in c is specifically a plus c. So don't think like that. Think of c as a constant. So this is saying for any constant c, Whereas I like to say A, capital A, just to make it a little bit, so you don't get confused. I think in school you guys would have used little c and capital C. Oh, good teacher. Your teacher? I don't even remember this. Okay. All right. The reason why I say good teacher, that means if they're using A, it's at university standard. That's how it should be. Anyways, so this is like that. There you go. Yeah, wouldn't have done it yet, differential equations. Done. Where A is any constant. Okay? Queenie, you're okay with that as well? That last step you'll get used to. That's nothing. Because you just get rid of all your constants pretty much in front of your explanation. Look, let's recap. What a straightforward question. All you got to do is keep your x's on one side, your y's on the other side. Then once we've done that, we integrate, and then solve for y. That's it. You're doing everything you could have done just last time. We're doing it again. I'm not going to do the next bit. Sketch the solution for c equals to 0 or a equals to 0 in my case, now that I changed it. A equals 0, a equals plus minus 1. That's just sketching. I'm not going to do that. Got nothing to do with this. All right, find the particular solution which passes through 0 and 2. Find the particular solution. Here we go. Ready? Look on top. The general solution involves an arbitrary constants. So what we just found was the general solution, obviously. If the particular solution to a differentiation equation involves substituting initial values into the general solution, obvious. I hope you would have done that. So find the particular solution which passes through 0 and 2. What are you going to do? Sub x equals 0, y equals to 2 into here. Sub x equals 0 and y equals to 2. Mariette, you're keeping up with us? Is this all okay?
Yeah.
You should get a equals to 3. Can somebody confirm? All good? Okay. And then therefore you get y equals, your particular solution is that. At that point. Sorry, passing through that point. Okay, and then find the equation of the tangent to the particular solution. All right, what do you do? Differentiate 9e 3x, then you want to find your tangent. So
Y minus.
Yeah, not yet. You got to find your gradient first, right? Sub it in 0 and then y minus. Y minus y1 equals 9x minus 0. And then you should get y equals 9x plus 2. Easy. Easy, 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 easy. If you keep telling yourself it's meant to be what I've already done before. With minor changes. Just let me know when you're ready to move on. I'll move on. X is on one side, Y is on the other side. It's going to be your biggest rule you want to remember. Everything's in play.
So always start like that?
Yeah, pretty much. Because it's always going to be Y dash, you've got to get it into Y. So you're always integrating. That's going to be the idea. Oh, we had so much room.
Yeah.
Okay, extension 2 HSC. That would be good to do. Not now. I'll let you guys do. Wait, do we need more questions right now? Or you want to just keep going? Up to you. What do you reckon? One more?
Yeah.
One more. Let's pick one up from question 1. G. Verify this is a general solution to this. There's a few ways of doing it. It's either you use differentiation or you use integration. What do you want me to do?
Is there one that's better?
It depends. Each question is different, but let's do it through solving it, which means we're going to integrate. So we start with this: dy on dx equals negative y. What's my next step?
So I just write the question.
Yep, you're fine. What would be my next step? Hey, that's not just you, anyways. To anybody. What would be your next step? Come on. Bring y's on one side, x's on the other side.
Oh.
Why are we stalling? Next step. Bring the y over. Bring the dx over. Is there such a thing as this line? Except in my u sub, you should never see it. So, what are you going to put in front of them? Integrate. There we go. That looks good. Quick. What's the integral of 1 on negative y? Well, forget the negative. What's the integral of 1 on y? ln. Yep, minus ln. That's it. We're getting faster. Integral of 1 x plus c. Remember, we want it to become an exponential. So let's hope it becomes an exponential. Well, let's do it like this. Minus x minus c. Y equals e to the negative x minus c. And then true. You see how we wanted like CE negative, and that's why it's capital C. Do you see how we wanted capital C? So you don't get confused with, oh, but I've got this, whoops, I've got this, where am I? I've got this E negative C, like how come, how do I, it's so wrong. No, you got to remember, you got to get rid of your constant terms. And the way we do that is multiplied by e to the negative c, and then that can become just anything, a. And I just wrote this extra bit for you guys. Okay. One more? You sure? Okay. Yeah, that's it. Because we're going to keep doing them. They're going to be the same thing. Even if this is differential equations. It's not like I'm going to do anything else. First order ODEs. I think you only do first order. You don't do second order stuff. Second order's university. First order is what we were pretty much doing. All this fancy stuff you don't need to worry about too much. Let's do it. Let's just do it. Just do it. The way I teach, when it gets close to the end, like where we are up to now, I should have taught in a way where I shouldn't need to teach anything new. That's the way I teach. So that's why I just go, just do it. So come on. dy on dx equals 1 on y squared. What do we do? What are you going to do? You're going to bring the y's here. You're going to bring this over. So it's going to look like this. Go. What do we do now? Integrate. Integrate, integrate. Y cubed over 3 equals x plus c. And then times it by 3 and then cube root it. So the idea is you're not meant to really leave it as like 3c. That's the logic of them. Because why? You'll see for questions. You'll see why we don't do it, because you don't need to. A would just be a lot easier because you're only trying to find a constant anyways.
Makes sense.
You'll get it, yeah.
Do we always write?
It's not wrong, just so you guys get clear. Like 3C is obviously not wrong, but it's just that it's unnecessary because it's constant. So we leave it as A. But sorry, go ahead.
Do we always need to write that where A is
Where A equals 3C? No. You can write A as a constant. You can write anything. It just looks funny to somebody who doesn't know who you are that you're going to go from a 3C into an A. That's why I think it's good to do where A equals 3C. You said, do you need to? In the exam, the people who are going to be marking your stuff, they already know all this. So no, but you should. It's good. All right, keep going. See how there's all these different cases, but again, the way I've taught it, we don't need to learn anything new. We don't. Hopefully. Let's see. Solve y dash equals negative 2x ey. What am I going to change y dash to? Sorry, page 18. Okay, found it. I think change it to dy dx. Don't use y dash. You'll confuse yourself. Next line, what are you going to do? Tell me your next line, if you know it. Slowly, if you have to.
You put the Y's in there.
Say it to me then.
You separate them.
Yeah, no, I'm saying you're right. Tell me what it becomes.
dy over dy.
Yep.
Equals dx, or no, minus 2x dx.
Yeah, usually keep the dx at the end. And then integral. Beautiful work. Obviously, you can't integrate 1 on ey. Please. You have to remember you got to bring it up as e to the negative y. Then we integrate. So then that becomes negative e negative y equals negative 2x squared onto plus c. Multiply by negative. Log both sides. And then get rid of the negative. Mariette, how are you going?
It's all right.
Only all right? You're not finding it like really easy?
It's not that bad. Like I thought it would be a lot more complicated.
No. There's nothing actually. We're not learning anything new except this last line, I guess. The fact that any constant can just become a plus a. Is that what your teacher told you? I hope so.
Or he doesn't like d plus d.
Okay, yeah. So it's very important that you guys get something because some of you might be looking up the answer here and thinking, how come you got a minus c and this is a plus c? Remember, these c's are two different c's. This is little c, like constant c. This is capital C, like my capital A. Why is it plus? Because remember, any constant can be anything. Any other constant. Is negative 2 a constant?
Yes.
Yeah, is 2 a constant? Yeah, they technically can be both the same thing. They're part of constant families. Now, would it be wrong if you had left it as minus c? Again, no, it wouldn't be, because when you sub it in, find the solution curve through 0, 0, it will give you, like let's say this. Imagine A was 2. Imagine A was 2. A, just hypothetically, imagine A was 2. What would little c what would have c little c became minus 2. You get the idea, yeah. So the answer for A and C are going to be different, but by the time you actually do the math, they'll end up to be the same thing. Good? All right. Rub. So I'm saying it doesn't matter. Like you could have left that as minus A if you really wanted to, but no one does that. We change everything to a plus A because they'll already fix everything up. Okay, done. And then find a solution curve. What are you going to do? Obviously, you're going to get rid of A, right? Because you want to find your constant. Sub in 0, 0. Negative exponential of 0 is 1. Therefore, y equals negative log x squared plus 1. Whereas if you did it from here, and I'll show it to you guys, 0, x squared minus c. E to the 0 is 1. Sorry, that's 0. Minus c. You would have got c equals to negative 1. See? Same. Then you would have subbed in c equals to negative 1. And then what would you have got? Negative log x squared plus 1. Same conclusion. That's why we do that. Because we know when it's just a constant, you can label it from another constant. It doesn't matter. That's all you need to know anyways. All right, move. I'm not going to do that. You guys will do this all, I'm sure. 4 marks. Wow. VCE. All right. I'm going to stop our recording and I'm going to get you guys doing it.